Hello everyone, I'm Frank and welcome to Learn How to Sudoku, where we take a very easy variant Sudoku puzzle and we break it down in detail so that you can learn how to Sudoku. Today's very easy puzzle is called Schizophrenic by Hengist, or Hengist. Hengist is probably the correct pronunciation. I don't know. Anyways, let's get to the rules. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit from 1 through 9 such that there are no repeats in any row, column, or designated 9-cell region. We have region sum lines, where box borders divide the blue lines into segments with the same sum, and different lines may have different sums. So, for example, these three digits must sum up to the same sum as this digit and the same sum as this digit. So say you had 1, 5, and 2 here, and then this would have to be 8, and this would have to be 8, because the sum of these cells on the segment must sum up to the same sum as other segments, which are gained by basically having the box borders divide the line into those segments. So that's an example of how region sum lines work. We have German whispers, where adjacent digits along a green line must have a difference of at least 5. And I call them whisper 5 lines because basically a setter came up with this designation of these lines. And I thought it was great because you can easily extend it to other types of lines. You could have whisper 6 lines, whisper 7 lines, whisper 2 lines, whisper 3 lines, etc., etc. So know when I'm saying a whisper 5 line, it's basically the same. It is the same as basically a German whisper line. And an example of how a German whisper 5 line works is, say you have a 3 here. Then this digit could be 8 or 9 because those are the only digits which are 5 or more away from 3. And that's an example of how a whisper 5 / German whisper line works. We have Renband, where digits along a magenta line form a set of consecutive, non-repeating digits in any order. So this could be something like, say, 3, 5, 6, and 4. And this would be valid because 3, 4, 5, 6 is a set of consecutive, non-repeating digits. What you could not have is something like 3, 5, 7, and 4 because 3, 4, 5, 7 is not consecutive. And that's an example of how Renband lines work and don't work. And then also we have an X, where digits in cells joined by an X sum to 10, and not all X's are necessarily given. So for example, if this were, say, a 3, this would have to be a 7 here, because these two digits must add up to 10, because there's an X between them. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's learn how to Sudoku. Okay. So let's start with the region sum lines, because we have 3 unique digits in each, adding up to another digit. So that means the single digit must be from 6 through 9, because the minimum for 3 unique digits adding up to another digit is 1, 2, and 3. That's 6. And the maximum a single digit can be is 9. So that's why it's up to 6 through 9. So this is 6 through 9. This is 6 through 9. This is 6 through 9 here. And this is 6 through 9 here. This digit. So all of these are high digits. On a whisper 5 line, you'll always alternate between low digits, which are the digits 1 through 4, and the digits 6 through 9, which are high digits. And the reason why you know that is what digits can be next to a low digit. 1 can be next to 6 through 9, 2 can be next to 7 through 9, 3 can be next to 8 or 9, and 4 can only be next to 9, all of which are high digits. So next to a low digit, you have to have a high digit, and it works the same way for high digits. What digits can be next to a high digit? 6 can be next to 1, 7 can be next to 1 or 2, 8 can be next to 1 through 3, and 9 can be next to 1 through 4, all of which are low digits. So on a Whisper 5 line, you know it alternates between low and high digits. So that means we can just pick a set here, and we'll say, hey, this is a certain set. We're going to make this, I don't know, orange. And the next to that, it has to be the other type of set, right? So we just make that yellow. Therefore, that's next to the other type of set. So that's orange, which must be next to a yellow. So these are both of the yellow set. These are both of the orange sets. And we could do something similar along each Whisper 5 line. So this will make dark and medium. And this, we'll make it, well, I guess maybe we can make this dark and medium. Maybe we'll make this, you know, let's make this green and pink. And this will, this is pink. And this will make orange and yellow because it fits where they are in the, well, not completely, but this will make dark and medium. So this is dark, which makes these both medium. Okay. What does this tell us? I am not sure. We know the digits on the region sum line can be at most 6. Same with these. This is at most 6. And these must be at most 6. Because 1, 2, and 6 adds up to the largest digit you can have, which is 9. Obviously, this digit cannot be in these cells. Oh, these digits cannot be the same as these cells. Then where, and these digits are the same. Where is this digit in this upper central box? Can't be here because that digit is in that row. Can't be here because that digit is in the row. So this must be the same digit as this. Right? Because there's no other place for it in the upper central box. Can't be here because that's the same digit as that. Can't be here. And it can't be here because along the lines, that same digit cannot add up with 2 other digits to add up to itself. So it has to be here. So these 4 are the same digits. And if we had them add up to 6 or 7, these would have to be 1, 2, or 3 if it's 6. These would have to be 1, 2, or 3 if it's 6. And that doesn't work because we'd have 4 unique digits in row 2 having to be 1, 2, and 3, which is not allowed. It's the same thing for 7. If you have all of them add up to 7, this is 1, 2, and 4. This is 1, 2, and 4, and we'd have 4 unique digits in row 2 trying to add up, trying to contain only 1, 2, and 4, which was 4 cells, I should say, trying to contain 1, 2, and 4. So this cannot be 6 or 7. It's 8 or 9. This is 8 or 9, and this is 8 or 9. So these are all the same digit. This must then be 1 or 2. Where is this digit in this left central box? This is the same as that, so it cannot be here and here. And this Renban means that it can only be at most 5, which obviously is not that digit. Right? You could have 2, 3, 4, 5 on this Renban at most. And therefore, this digit is not the same. Cannot be here, cannot be here, cannot be on the Renban. It has to be the same as this digit. So this is also 8 or 9, and it's the same digit here. Okay. Well, where is 8 or 9? This digit, which is the same digit, where is it in the central box? Can't be here, can't be here because of 8, 9's in the rows. Can't be here or here because of 8 9's in the column, so it has to be here, which means these are both high digits, and the greens must be low. And this is specifically the same as this. Where is this digit then in column 2? Can't be here because of 8, the digits in the boxes. Can't be here because of the digit in the row. Can't be here because that digit plus 2 other unique digits in normal Sudoku cannot add up to itself. So it has to be here as 8 and 9. And we have 8 of those. We have this 1, 2, 3, 4, 5, 6, 7, 8. We know where the last one is. It has to be there. So this is 8 or 9. This is next to at least 2 unique digits on a Whisper 5 line. So this is 7, 8, or 9 here. This is the same digit. What else do we have? This is next to 2 unique digits on a Whisper 5 line. So it's 1, 2, or 3. Same as this. And this could be 1 through 4 here. We don't know. These are 2 low digits. Anytime you have 3 unique digits adding up to a single digit in normal Sudoku, you have to have at least 2 of the digits be from 1 through 3, right? Let's just work with 8 and 9 because we've ruled out 6 and 7. But 8 can be 1, 2, 5 or 1, 3, 4, which contain 2 digits from 1 through 3. 9 can be 1, 2, 6, 1, 3, 5, or 2, 3, 4, also, which require 2 unique digits out of 1, 2 out of 1, 2, or 3 in that set. So we know there are 2 digits from 1, 2, or 3 here, and these are both low. So we're guaranteed that this has to have a 4 here, right? Because 2 of these are from 1, 2, or 3. So only 1 of 1, 2, or 3 can be here. Therefore, the other must be a 4 here, guaranteed. Since this is 4, this has to be next to a 9 on a Whisper 5 line, which means the unique digit we have, then, that these sum up to must be 8. So this is 8. This is 4 here, so this cannot be 1, 3, 4. We also can't have 6 in any of them. So now this is 1 through 5. This can't be 6. This cannot have a 4, so it has to be 1, 2, and 5, which eliminates 1, 2, 5 in the rest of the box, so this is a 3, 4 pair. That leaves 6, 7, and 9 remaining in this upper central box, and this 3, 4 pair eliminates 3 and 4 in the rest of the row. This cannot be 1, 2, 5, though, because if it's 1, 2, 5, that would mean, again, in row 2, we would have 4 cells requiring only 3 digits, which is not allowed. So this must be 1, 3, and 4. This can't be 3 or 4, so this is 1, which forces this to be a 3, 4 pair to add up to 8. And here, if we try to have this being low, this being high, and this being low, we already have 3 lows in the box, which means we cannot have another 2 lows, so these must be high, and this must be a low here. So this is 2 as a low. 2 can be next to only 7 or 9 remaining out of 8, so this must be a 7, 9 pair, which forces this to be a 5, 6 pair, which eliminates 5 and 6 in the rest of the row, so this can't be 6. This 6, 7, 9 triplet, and this 2 eliminates 2 here. The 6, 7, 9 triplet eliminates 6, 7, 9 in the rest of the row, so we have the remaining digits as 1, 3, 4, 5. This is 2 then, and is low. Remaining digits in row 3 are 2, 7, and 9. Remaining digits in row 2. This is guaranteed 2. You could have 1, 5, 6, 7, 9 are the possibilities. 1 can never be on this ren band because we can't have a 2 there. And 1 can only be consecutive with 2. 9 cannot be here because you have the same problem. 9 can only be consecutive with 8. So this can't be 3 because it would need 4 or 5 there, or 4 and 2 there, and 4 can't be there and 2 can't be there. So you could have 4, 5, 5, or 6, and those are the possibilities, and we have a guaranteed 5 here, which eliminates 5 in the rest of the column and the rest of the box. So this can't be 5, that can't be 5. These cannot be 9 because 9 can only be consecutive with 8. So you could have 1, 2, or 6, 7. So it can't be 7 there. 2 has to have 3 and 4 guaranteed for 4 length renban. And it could either be with 1 or 5. So this is 3 with 1 or 5. Whereas 9 in this left central box cannot be here because of 9 in the row. So this must be 9 here. 9 eliminates 9 in the rest of the column, so this can't be 9. This is 7. This can't be 7 or 9. It's 6, which makes this 9 there. These are all high. And 9 eliminates 9 here, so that's 7, which makes that 9. This 7 eliminates 7 here, so this is 2 and 1 to be consecutive. This can't be 2 or 7. It's 9. So that's a high digit. 1 cannot be here. 2 cannot be here. 1 cannot be here. 5 can't be here because of the 5 pairing. This has to be 5 to be a renban correctly here. We have a 1, 3, 4 triplet, which eliminates 1, 3, 4 in the rest of the column. So this can't be 4. It's 5, which makes that 6. No more 1 here. This 1 eliminates 1 in the rest of the row. So this becomes a 2, 5 pair. This can't be 6 or 9. It's 7. This 2, 5 pair eliminates 2 and 5 here, so that's 1, which means this can't be 1 here. Remaining digits in column 2 are 7 and 9, and this can't be 9 because of 9 in the row, so this is 7, which makes this 9 here. This orange cannot be 6, 7, 8, or 9, which are all highs, so it has to be low. So all the oranges are lows and all the yellows are high. This has to be 3 or 4 next to a high because it can't be 1 or 2. And it can't be 8, so therefore this must be 9 here. This can't be 8. This is a low. These are all lows, guaranteed. 5 and 6 is consecutive with 4 through 7, but this can't be 7 because of 7 in the row. So this is 4, 5, or 6. We have 4 low digits in row 5, which eliminates low digits in the rest of the row. This can't be low, so it must be 5, which makes this 2, 3, 4, and 5 to be a renban, which eliminates 3 and 4 in the rest of the column, so this can't be 3 or 4. It's 1, which means this can't be 1. This can't be 2, so if this were 1, 2, and 5, this could not be 5 here. We can't be 5 because of 5 in the row anyways. This is low, guaranteed. This is low. We have low here. These are high. Remaining digits of row 5 are all high. So this has to be a 6, 7 pair because it cannot be 8 or 9. And this can't be 6 anymore. So this is 4, 5 here. So one of these two is definitely 5. If this is 4, that's 5. If this is 5, obviously it's 5. So they both see this cell, so this can't be 5. That's 6, which makes this 5, which makes that 4, which makes that 3. That makes that 2 and 1, and 4 and 3 there. This has to be a 9 because it's the only high remaining in row 5. This is high. This is a 1, 6 pair. 1 cannot be here because of 1 in the column. So this is 6, which makes this 1. So this is high, and this must be low. This is high. let's see. Remaining digits have to be 5, 1, and 2. So this is low. This is high. Remaining digit here cannot be 5, cannot be a high, so this is low, and cannot be 2, 3, and 4, so it's 1. This then must be a 2, 5 pair. This can't be 2 because of 2 in the column, so this is 5, that's 2, and this is low. That means this can't be 2 or 4, it's 1 or 3. Remaining digits of row 4, 3, and 5. Remaining digits of row 6 are 4, 6, and 7. This can't be 6 or 7 because of 6 or 7 in the column, so this is 4, which is a low, which means this can't be 4 here. So that's 6 and 7, which are both high. This must then be 5 through 8, and it cannot be 6, 7, or 8 to be consecutive with 6 or 7, so this must be 5, which makes this 6 and makes that 7. 5 eliminates 5 here, so it's 2 and 5. And this is 2 as a low. 5 eliminates 5 here, so it's 3 and 5, which makes 3 a low. 3 eliminates 3 here, so it's 4 and 3. This has to be 1 or 3 also. And this is 1 or 3 in the rest of column 5, but this can't be 1, so that makes this 3, which makes that 1. So this is also a low. This can't be 6 or 8, it has to be 7 or 9. 7 eliminates 7 here, so that's 6 and 7. 5 is there, that's fine. Okay, remaining digits of column 4. We have 2 and 6. Okay, so that's not helpful. Remaining digits of column 6, we have 4, 7, 9. This can't be 9 because of 9 in the row. Remaining digits of column 8, we have 3, 4, and 2. 2, 3, 4. Remaining digits of column 9. We have 4, 6, and 7, which eliminates 4, 6. Okay, this 4 eliminates 4 here, so this is 3, which makes that 4. 3 eliminates 3 here, so that's 1. 4 eliminates 4 in the rest of the column, so it's 2 and 3. Remaining digits of column 7 are 5 and 9. And this cannot be 9 because of 9 in the row. So this is 5, which makes that 9. 5 eliminates 5 as a possibility here. So this cannot be 1, 2, and 5 adding up to 8. It's 1, 3, and 4. This is low. We have a 3, 4 pair in column 2, or column 1, which eliminates 3, 4 in the rest of the column. So this must be 2 and 7. And we have a 3, 4 pair in column 3, which eliminates 3 and 4 in the rest of the column. So this is 5 and 6. This can't be 5 because of 5 in the row, so this is 6, which makes this 5. 6 eliminates 6 here, so it's 2 and 6. 2 eliminates 2 here, so it's 3 and 2. 2 eliminates 2 here, so it's 7 and 2. 7 eliminates 7 here, so it's 4. This can't be 9 because of 9 in the row, so that's 7. And therefore, this is 9. 4 eliminates 4 here, so it's 3 and 4. 3 eliminates 3 here, so it's 4 and 3. This can't be 4 or 7. We have to celebrate the 3 in the corner because we're close to solving it. This is 6, this is 4, and that's a 7. Yeah, pretty cool, actually, how these all sort of, where this digit could be. That was basically the break-in here. And it was sort of just recognizing that. Yeah, nice little puzzle here. Either way, I hope you enjoyed this solve, or this episode of Learn How to Sudoku, and I'll see you next time on Frank Puzzles. Take care.